What if I told you that even after a hacker steals your encrypted password vault and cracks it open, they still can't tell what your real password is? That's not a fantasy, that's honey encryption. Honey encryption, a clever cryptographic trick that fights back against the brute force attack in a way traditional encryption simply can't. Hello, I'm Harsh, and today we are breaking down one of the most elegant ideas in modern cybersecurity, honey encryption. So stick around because this one genuinely changes how you think about secrets. To understand why honey encryption matters, we first need to understand the weakness it's solving. When you encrypt a data, say a password, the encrypted output is called a ciphertext. Now, traditional encryption is strong, but it has one dirty secret. Like if an attacker steals your ciphertext and tries the wrong decryption key, they get garbage, obviously unreadable garbage. The garbage output is basically a signal. It tells the attacker, wrong key, try again. So keep trying. Thousands, millions of times they keep trying. This is called a brute force attack, and with modern hardware and short passwords, it can succeed fast. Traditional encryption doesn't lie, it just refuses to answer, and sometimes that silence is enough of a hint. So, honey encryption flips this entirely, invented by Ari and Thomas in 2014. So, this is designed so that every single decryption attempt, right key or wrong key, produces a result that looks completely valid and plausible. Here is the key idea: wrong key, you still get fake but believable plain text. Right key, you get the real data, but you can't tell the difference. Imagine you have a vault with a 4-digit pin. Normally, entering the wrong pin shows an error. With honey encryption, entering any wrong pin opens the vault but gives you a different, convincing looking fake document every time. You never know which one is real. So, the attacker is droning in plausible looking lies and can't distinguish truth from fiction. The magic is in something called a distribution transforming encoder or DTE. That is the process in plain English encryption style. Take your real data, say a password like sunflower99, use a DTE to convert it into a random seed value, a number that represents your data based on how common or likely it is. Encrypt that seed using a standard cipher. Now, decryption side, decrypt the ciphertext using whatever the key the attacker tries. This always produces some seed value. The DTE then converts that seed back into the plausible looking output. The critical piece is this: the DTE is designed based on the statistical distribution of real world data, so fake outputs are not random garbage. They look like actual passwords, credit card numbers, or messages that someone might really use. The attacker gets a realistic looking password every time. They just have no idea which one is real. So this has some really exciting real world uses like password managers. Even if a hacker grabs your encrypted vault, every brute force attempt gives them a different valid password. They can't tell which one actually unlocks your bank account. Now another one is healthcare and financial records. Encrypting sensitive records with honey encryption means a stolen file reveals nothing definitive even under sustained attack. Authentication tokens. The tokens can flood an attacker's pipeline with decoys. The beauty here is that it shifts the attacker's problem from keep guessing until I find garbage output to keep guessing but I will never know when to stop. So the honey encryption isn't a magic and it's not everywhere yet. A few honest limitations. The DTE has to be carefully designed for each type of data. A DTE for passwords is different from one for SSN or emails. If an attacker somehow knows your exact data format very precisely, it makes the plausibility harder to maintain. It adds complexity to the encryption decryption pipeline, which means more surface area to implement correctly. It's most powerful in combination with other defenses, not as a standalone solution. Honey encryption is one of those ideas that's both technically clever and genuinely intuitive. It doesn't just protect data, it actively deceives anyone trying to steal it. It's still a relatively niche technique, but as password breaches and brute force attacks keep making headlines, the ideas behind honey encryption are more relevant than ever. So, if you found this interesting, drop a like and subscribe. I cover topics like this regularly, and let me know in the comments what other encryption topics do you want me to break down next. See you in the next one. Thank you.